Hello, folks. This is Jeff White from Dell Technologies here speaking to you today at the SNIA Compute, Memory, and Storage Summit. My topic that I will discuss today is Edgenuity, the intersection of Edge and AI. At Dell, I work in our Office of CTO, working on Edge research, and I also am part of our Edge business unit leadership team. So Edge and AI have a long history together. Edges, we'll talk a lot about edges and the creation of the modern edge and how artificial intelligence has been a critical workload that edges support, and increasingly technology that is used to realize and manage scaled edge deployments. So without further ado, let's get into the material here. So first of all, let's talk about modern edge computation. Edges have a long history, both in telecommunications, in industrial settings, and many others. They were realized through what I call embedded systems. So hardware that is tightly coupled with the software to create predictable performant outcomes. So bespoke hardware control. But this leads to some challenges historically that are driving us toward the modern edge. First of all, that the systems are tightly coupled to the hardware. So to make changes, you have to really consider both the hardware and software environment in detail. And this leads to challenges in terms of how to flexibly make changes in a limited amount of time. Secondly, it creates fragmented systems. And this leads to quite a few issues, such as limited ability to share data, the inflexibility I referred to, but also closed systems because edges are very much open. Each different type of application, whether it be a sensory application for visual inspection or a self-checkout lane in retail, or some type of computer vision application for security or worker safety. All of these different capabilities end up being individual systems with their own support, their own hardware, their own software, usually their own access to cloud, and of course their own data structure. And many times these systems require on-site expert support. And one of the most important things, each of these systems has their own security policy. And historically, the assumption was that edges would not be connected to the internet. And as we know today, everything is connected, everything is online, whether you know it or not. And therefore, this leads to the ability to create exploits and security vulnerabilities. So the future, the modern edge. So the future is now, as has been said many times. We migrate the embedded systems to a common system platform, which is higher computational power, is a shared system. We use software multi-tenancy techniques, is open so that you can mix and match different types of applications, different types of hardware accelerators, different types of configurations and capabilities to achieve a broader set of outcomes. You can support the modern edge remotely. You don't need on IT support. In fact, Dell's system, we leverage zero-touch onboarding, which I'm sure many of you have heard. But true zero-touch onboarding technology is really being created today by Dell. So unified security policy, very, very important. So similar to other architectures like cloud and IT, you can protect the underlying software platform and hardware platform with a unified policy where each application is responsible for its security requirements. This is a modern technique in IT and is largely effective. Still many issues to deal with, supply chain tax, et cetera, but with a well-designed modern edge, you can create a much more comprehensive security policy. Power efficiency, because you're running things on a fewer number of systems that have higher computational power. And of course, it's enabled for modern workloads like AI, dynamic twins, digital twins, but many, many other workloads that we'll talk about today. So modern edges must be secure, must simplify the very complex requirement of managing very, very workloads that are uh, intensive, mission critical, sometimes safety critical, as well as have real-time requirements. But most importantly, edges deliver workloads that provide an ability to meet a predictive performant outcome because of the nature of these workloads. Let's talk a little bit about use cases in the edge. So vertical use cases, the way we see things here, really four large buckets. So enterprise edge and telecommunications are here widely deployed with our customers across a variety of verticals. This is just a sample of them. There are additional verticals such as healthcare is beginning to be a larger one. The other side is telecommunications. As I said, many edges evolved from telecom, but there's a set of telecommunications capabilities around Open RAN and network function virtualization that also run in the edges. These are not separate things, they're tied together. In fact, edges leverage telecommunications and networking capabilities, as well as host network telecommunications capabilities and networking capabilities. Increasingly, we're seeing new areas develop of technology in terms of autonomous systems, so connected autonomous vehicles, robotics, UAVs, UUVs, underwater vehicles, soft robots, and robotic process automation. So a lot of autonomous systems are appearing. This is part of the evolution of AI. In addition, another area that we see a lot of workloads that are actually up and running today, getting beyond the emerging, is in what I call simulated extended reality. So this is consumer XR, sometimes known as the metaverse, the ability to enable enterprise remote services, digital twins, and simulation, two different things, but closely related, and an increasingly new workload with generative AI, 2D to 3D image construction. A lot of autonomous systems need to understand the 3D world to operate, not necessarily vehicles, could be material handling in a discrete manufacturing area or warehousing and logistics and transport. And as we all know from taking pictures, a picture or an image is a 2D image of a 3D world. So being able to reconstruct 2D images from cameras and turn that into 3D understanding is very important. Lastly, I'll say at the bottom that public sector and defense applications are growing fast and are a subset or a superset, excuse me, of all of these capabilities. So let's talk a little bit about AI technology. As I said, AI edges have supported computer vision and AI-enabled workloads for many years, usually using discriminative AI. So let's talk about the different types of AI that edges use. And in fact, edges leverage all types of AI. So from symbolic AI, which arose in the 70s and 80s and reached its height in the 90s, but it's making a big comeback. So this is reasoning systems. It's based on logical, symbolic ways of representing problems and then solving those using reasoning engines usually. Symbolic is making a comeback, with algebraic means and newer neurosymbolic approaches. And this is used in Edge primarily in the area of autonomous systems to help make decisions, complex decisions with emergent type behavior. Machine learning has been used in the Edge for quite some time. Machine learning is some of the first AI that was created. Think of it as support vector machines, decision trees. It's been used extensively in data analysis, things like principal component analysis and others. So traditional machine learning, which are statistical and probabilistic techniques to analyze capabilities, make decisions. One that's very popular is clustering with K nearest neighbors, is a very important AI technique in terms of data analysis and decision making. Reinforcement learning is a ability to create agents in AI. These agents either have a policy that is learned and through self-supervised learning or supervised learning, or they learn it actively by interacting with the environment. But the agents basically create a graph in the ability to solve problems and create control frameworks for the edge. It's been very popular. Reinforcement learning, however, has limitations in terms of the number of variables and number of systems it can control. Discriminative AI. So this is artificial neural networks. This is area of like convolutional neural networks, you may hear, recurrent neural networks, others. So discriminative AI is trained usually with supervised training, so a data set. You train a neural network. The neural network then will make output classification decisions. So given an input data, whether it's an image or text or audio or some other input stimulus, it will classify that data into classes that it learned in a supervised manner. And then lastly, generative AI, which is very much a popular topic today. Generative AI learns a joint distribution between inputs and outputs, so it can produce new data based on input data. Generative AI is not necessarily a large language model like ChatGPT or Anthropic's Claude. Generative AI techniques have actually been used for quite some time with capabilities called autoencoders. And what they do is they take complex data that's highly dimensional, like images or video or other high dimensional data. Audio is pretty high dimensional, and you encode it into a latent space, right? And then you can decode that data later after you manipulate it in a lower dimensional, what's called a latent space that's not visible. So there are generative AI techniques that are used in Edge and are emerging, and we'll talk about some of them. But you know, AI in general is a capability that it will learn a statistical and probabilistic task, and it will, whether it's classification, ranking, regression, clustering, and geometry discovery, density estimation for probability density function. But AI is most importantly understood as a universal function approximator. It is not the Terminator. It is not science fiction. I don't think it will ever achieve human level intelligence. However, that's just my personal opinion. But the capability of AI is really to be used as a universal function approximator. It can be used to automate intelligent behavior, but defining intelligence is a very difficult thing. Today, people talk about AI doing reasoning. What they really mean when they're talking about it doing reasoning is it can intelligently solve problems and apply these problems through a graph or some other means to come up with a reasoned outcome. And since AI can look at a large amount of data, and there are different types of training techniques, I mentioned supervised training, where you take a data set and you train it. There's also self-supervised training, where you give it part of the data and it extends and learns other data. Or there's unsupervised training, where it learns from the data that it's processing. From any of these areas, AI can be very useful within the edge because it can help us to make decisions. It can interpret the information, something called perception, in a visual sense, but it can help us to also make decisions. It can also help us to analyze data. And edges are driven by data. The reason we distribute this modern computation is to manage the immense amount of data that is being produced by sensors, by business processes, and it can draw insights from that data locally versus having to send it across networks and analyze it in centralized areas like cloud. So AI is important. It's a essential part of edges. So let's talk about some use cases of AI. So I won't go through all of these, but this is a sample of use cases, largely driven from the manufacturing vertical, but you'll see this across retail, across transportation, logistics, et cetera, et cetera. I have a few retail ones in like loss prevention. So quality inspection, using images to look at different types of production processes or checkout processes and make sure that they're working safely, worker safety, overall equipment effectiveness, robotic control, robotic process automation, predictive maintenance, et cetera, et cetera. Digital twins are increasingly using AI capabilities to make decisions like the 2D to 3D modeling I mentioned before. And they really come down to four different broad categories. So machine vision or computer vision, So this is taking imagery, whether it's video, whether it's pictures, or whether it's some other type. It could be LiDAR data, which is three-dimensional data from a device called a LiDAR, and interpreting that information to make decisions. Near real-time analytics. And so real-time analytics is taking a look at structured or unstructured data and being able to draw insights from that using AI techniques. So some of the techniques used in this are machine learning focused techniques and increasingly some generative AI techniques. Machine vision leverages convolutional neural networks. This is a discriminative AI approach. Vision transformers may appear in the future, but the transformer architecture, which underlies generative large language models and foundations models, is not very computationally efficient. So there's a lot of work on how to use generative AI and machine vision. It's a very hot topic of research. Residential networks, multisensory inference are also areas for machine vision. Autonomous system support. So reinforcement learning, transformers and generative AI will be used with autonomous systems. There's a lot of exciting stuff there. Work going around with both generative flow networks, which is a type of generative AI, as well as areas for like stable diffusion and diffusion-based systems to create scenarios for autonomous systems to do high-level reasoning. Multimodal capabilities. This is where you use different types of AI to achieve an outcome. And then data processing and analysis. So the data that comes in, we have to perform ETL functions, extract, transform, and load. So a lot of data has to be pre-processed. In fact, in a machine vision pipeline, some of the first things that's done is downsampling and standardizing the images so that the model can interpret the images in a standard way. The interesting thing about this is that all of these different AI techniques that are used in Edge build upon each other. It's somewhat of a networking effect. As I just mentioned, machine vision requires data pre-processing. Well, a good way to do data pre-processing is to use AI techniques like autoencoders, transformers, principal component analysis, random forest, etc., to do this type of analysis, especially as it gets more complex. Autonomous systems need to do 2D to 3D rendering, which can leverage generative AI, which leverages machine visions to create the pipelines. And of course, everything, whether you're interpreting data discriminatively and classifying it based on an output class, or you're manipulating data to transform it into something else that can be used, you need to have actuate controls and commands. So for instance, in worker safety, what we're increasingly seeing now, it used to be just detect if a worker did not have their hard hat on or their proper protective safety gear. It would detect that, it would put a red bounding box around it and alert someone in management or control that there was an unsafe situation or that someone was in an unsafe area, say in a factory or in a transportation hub, etc. Today, we can take AI and actually stop the machinery before there's someone gets injured. So you take the near-time, real-time analytics, you found out that someone is in an area that's unsafe, that they could be potentially injured. So now we can take affirmative action to stop the process to make sure that the person is not injured in this area. Just one of the examples. Security is another huge area. So I hope that gives you an idea of the AI use cases around which are being used. We have something here we call AI in, on, and for. So we leverage AI in many of our products at Dell, including Edge. We also, so that's AI in. At Dell, we also say AI on. Okay, so this is us building capabilities to support AI workloads, which I've largely been describing, and we'll talk in another slide on the AI operations and how we're using AI in. But what I've described primarily here is AI on, where we take AI workload as a workload and we support it on our platforms. And then there's AI for. So this is Dell using AI internally to help us develop products, to help us make an efficient operation, manufacture better, etc. So in, on, and for is really what AI is about. And this is a term that was coined by our Office of CTO organization under John Rose 5 or 6 years ago. So AI operational support function. So I've talked about AI on up until this point, where we're really supporting AI as a workload in Edge. But edges themselves require the ability to leverage AI as well. So in an operational framework, I've drawn a diagram here. So there's a lot of training. Largely, the training is done today outside of the edge. It's done in the cloud in the core. This is because training requires a forward and a backward pass through data, requires a tremendous amount of data, a tremendous amount of computation, which is much better done in a centralized location with high-powered GPUs from NVIDIA or AMD or some of our other good partners at Dell. So, the data science and engineering, designing the models and then training the models, this training process I just described occurs in the core. However, operationally, there's something called inference. So training is making the model work and achieving your objectives. Inferencing is actually putting the model to work where it can make decisions, it can interpret data through a perception pipeline. That's what largely occurs in Edge. So if you look at it, models are staged into the edge, into a complex environment managed by our Edge software-defined platform at Dell, our native Edge capability, or others. So the models are staged into the edge. The models are then deployed. Things we have to think about that we leverage AI for here is security. So how do we keep the models secure? They encode a lot of data, a lot of intellectual property, and increasingly with generative AI, it's possible to reverse engineer the training data set by using the model itself. So you want to secure this information and make sure that it doesn't leak out, doesn't become exploited, or you lose your intellectual property. AI ops is actually operating the inferencing process itself. So this is creating streams of data in some cases, or data sets, or providing access to applications that can actuate, make changes. So this is creating a pipeline, usually, of inferencing information, particularly in computer vision, and how that is managed. Also, there's something in large language models called retrieval augmented generation, or guardrails. Okay, and what these AI, when a large language or generative model inferences, there's prompts engineering. This is the information that's being put into the model. However, in order to give the large language model context, as well as make sure that its replies are appropriate, you use techniques to generate this capability, and that technique is called RAG, Retrieval Augmented Generation. And it has very many variants, but basically you provide additional information with the end user prompt so that the AI model has context. It also has information that will direct it to give a more accurate response. So a lot of these capabilities are run in the edge, along with security, AI ops. This is part of LLM ops and large language model ops. And this is a distributed capability that we're starting to see more and more and more. This is also something that can be leveraged in the edge for actuation control, sensory image detection, something called multimodal models. So with all of these functions defined, this capability is leveraged quite a bit in Edge for control. So for instance, one of the things that we've done is with our domain-specific language and creating what we call blueprints, we've created a copilot with AI. We're also using it to analyze telemetry and make control decisions in edges themselves. So a really exciting area. I think my time is just about up. So I'll just leave you with the future of AI, multimodal, generative, and discriminative techniques working together. This is a very important area. You might hear terms like mixture of experts, or multimodal AI capabilities. This is really a powerful technique that's coming to Edge. So generative and discriminative techniques. Agent-based design. Edges are going to be increasingly designed based on agents that make decisions. So they'll be leveraging capabilities of machine reasoning. Interactive distributed training. I said most training is done locally or in a core area. What we're going to increasingly see is distributed training, federated learning being deployed. These techniques exist. They haven't been largely deployed, but with generative AI, with other enhancements to AI in the area of reinforcement learning, I think you're going to start to see a lot of self-supervised training that is actually involves edge and distributed models. And then, of course, AI security. One of the things to think about in AI security is that you need to really think about how you protect the models themselves, but you also have to think about how you protect the platform from the models, since they can be trained to do quite a few other things. So appreciate your time. Please send questions. I'll be happy to follow up. You can see my email there. And I really appreciate SNIA giving me the opportunity to speak today. Thank you.